So in double hashing, what I do is, rather than fixing the hash function, I also change it. So example, I want to find out that room, otherwise memory location, which this element k should go. K is a k. K is the key. Then I apply first of all h1 of k. When I value 0, what happens? You see, when I value 0, this entire second function will be 0. Then we do like normal h1 of k, like as we are doing. So second time what I do is, when I value 1, then I try h1 of k plus h2 of k. That means you have two hash functions which are mixed. That's fine. It will perform better than this linear probing and quadratic probing. Now what we do is, first we try with some numerical values, like how this double hashing works. After that we will see the analysis part. In double hashing we use two hash functions. Example, here you see h1 of k and h2 of k. So how I am going to do is, example, I want to create a sequence, probe sequence. So I is nothing but the sequence number. First time in the 0th sequence, hd of k comma I. So this is what your hash sequence, k comma I equal to first hash functions k value plus h2 of k into I percentile m. Let's take an example. Example, k value, let's say the array size is 13. That means m value is 13. Then what happens, we'll see. We need two hash functions here. One hash function, let's say h1 of k, which is general hash function I take, which is nothing but k percentile 13. So I need another hash function h2 of k. So that would be, let's say, just one smaller than 13 I take. That would become k percentile 12, let's say. Okay. Now we are going to use these two hash functions to generate the probing sequence. How we will see. Example, if 26 comes first. If 26 comes first, then according to this formula, hd of k comma k here 26, right? What is the probe number now? 0th probe first. So always we have to start with 0th probe. Then formula for 0th probe is, this value will become, see, h2 into k, h2 of k into I will become 0. Then only it depends on first one, h1 of k. So h1 of k is 26, whole percentile m. So what is here h1 of here m value 13, right? So what is h1 of 26? So this h1 of k, 26 percentile 13 is 0, 0 percentile 13 is 0. That means 26 would go to 0. So finally this entire thing is depending on this hash function, because in the 0th probe h2 function doesn't have any effect. Now when you add one more element, let's add 13. If I add 13, what happens? Again this 13 tries 0th probe, correct? So we are going to always start with 0th probe. So this 13, for 13 0th probe is just h1 of k, correct? h1 of k, if you see 13 percentile 13, which is 0, then this is also coming here. So 13 would hit 0. Then what happens in any open addressing? We probe. What is the probing sequence here? See here, formula for second probing is, otherwise first probing is hd of 13 comma 1. This is what the formula. Let's blindly apply the formula h1 of k. So here 13, right? So 13 percentile 13. So what I want to say is, this is always fixed now. From now onwards it would be same for every probe. So I can say that already we know that h1 of 13 is 0. So 0 plus h2 of k this time, because I value will become 1, correct? In I value 1, then h2 of k will have an effect. So what is h2 of k here? K percentile 12. What is the value you are inserting? 13, right? So 13 percentile 12. Overall percentile m. M is always 13 in this problem, right? It would become 0 plus 13 percentile 12. What is that? Remainder 1. 1 percentile 13, 1. So it would go to this position, which is nothing but, this one 13, right? We have to insert. What I want to say is, in the place of 13, if you would have got 39, okay, no, in the place of 13, if you get 39, what happens, we will see. So here two hash functions, h1 of k, remember, k percentile 13, h2 of k, simply k percentile 12 we are using, correct? Okay, in the place of this 13, if you get 39, h1 of k same for that also, so that it will hit initially same position, because we try what, hd of 39 comma 0th probe. In zeroth probe, the sequence depends on only h1 of k. So the value will be h1 of 39. So h1 of 39 is nothing but 39% and 13 remainder 0. Correct? It would hit again here. So recall now. So we tried 13. Now we are trying 39. When you tried 13 and 39, because their hash value with h1 is same for 26 and 13 and 39, for these three, first hit will be 0. Why? Their h1 of k is same. But when you, so what we are doing now? We are mapping 39. So 13, so when you tried 13, it went to first position, remember it. So 13th first probe, that means, so first probe here, I mean, indexing starts with 0th probe, right? 0th probe is same for everyone. So 13th first probe was index 1, remember it. Okay, now 39th first probe we'll see. 39th first probe will be, what happens? I am applying the formula h1 of k, which is nothing but 0, plus h2 of k into I, which is nothing but 1 into h2 of k, which is k percentile 12. So 39 percentile 12. So for this one, for 13 it was 13 percentile 12. Here it is 39 percentile 12. So they give different answers, right? 13 percentile 12 is different from 39 percentile 12. Here you get remainder 3. So that means probing sequence would be changed, correct? So you get here 39. But if it is 13, it would have gone here. So that's the difference. So next time when you insert one more element, what happens, we'll see. So 13 comes here, 39 comes here. Let's try with same initial hash seed. That means, so we'll see one more number with 0 as base. Okay, so for that I take 52. For 52, what happens? First time when you try, so that means 52, if you try 0th probe, then it would be same like 26, 13, 39, that is 0. Second time what happens if I apply? So you will be probing now. The first probe will be h1 of k 0 plus h2 of k. What is h2 of k? K percentile 12. That means 52 percentile 12. So it would be remainder 4. See, it's going in a different place. In that way, so we are having different kind of idea here in double hashing. So you will have lot of probe sequences, right? It is not one particular probe sequence. So what I want to say is, here, because you have lot of probing sequences, there will be lot of randomization, right? We don't go like this. Example 26, 13, 39, they don't go in this formula like I plus I square always. That means a one particular fixed probing sequence is not there here. We have, so because of multiple hash functions, we'll have different lot of probing sequences. Okay, so we can prove that there are m square probing sequences approximately. Why? If you have only one hash function, it generates m sequences, we know that, correct? So this hash function is again appropriately is going to create, because this, did you remember? So the hash function's idea was what? h1 of k was nothing but just percentile 13, right? h2 of k was generating some percentile 12. Approximately it can also generate m sequences, right? M reminders. So this was giving m reminders. So what I want to say is, so this hash function can generate m sequences, this hash function generates m sequences. In combination, if you apply, then it would give m into m approximately m square probing sequences. You get m square combination of sequences, so that is definitely better than quadratic probing. So double hashing is the best idea so far we have in this open addressing. Generally people prefer double hashing over linear probing and quadratic probing. So linear probing, quadratic probing has clustering problem. This double hashing doesn't have clustering problem, I can say. We can somehow avoid it. How? Just see this scenario. I just tell you the difference between quadratic probing and this double hashing. Example, if you get 0, 13, 39, something 52, these elements in one order. In quadratic probing, so 0 first comes, then 0 goes here. 13 also will try to go here, but you apply some probing sequence. That means we apply I plus I square formula, right? So using I plus I square formula, if you try, 13 comes here, after that it will go to plus 2. That means 13 comes here. Then 39 definitely will try here, after that it will try here, then again it has to go, this time I plus I square, so I value will be 2, so in I value 2 then it would be 6 I think, right, 2 plus 2 square 4, then it would come to 6th position, so it would be here 39, then 52 would be something else, like, okay, so this is a fixed probing sequence. So in the place of this, if you use double hashing, what happens is, so 0 based on the numbers, probing sequence will be changed. Example here, 0, 13, 39, 52. If you get these numbers, there is only one fixed probing sequence in quadratic probing. If in the double hashing, what happens, you get a different probing sequence. Example, the probing sequence is something like this, maybe I'm just showing with picture. This is, let's say, probing sequence for 0, 13, 39, 52. If I interchange them, like if 0 comes after the 39, after that 52, after the 13, definitely the probing sequence will be different, and in that way there are m square different probing sequences possible, right? So that's why it will be better than linear probing and quadratic probing. In the GATE exam, what kind of question they ask is, they give simple problem, like they give an array, they give hash function, they ask what if linear probing is used, then how elements will be, arranged. Second one, if it is quadratic probing, how elements will be mapped. That's it. They are very easy questions. Okay, so don't worry about hashing. Hashing is very easy if you know what is linear probing, what is quadratic probing, what is this double hashing. That's it. You can answer any GATE question. Okay.